Okay, it's time for lesson 11, part 2. Add to the program we did in part 1, adding another path to the code we already had. So let's get started here. Let's get rid of me. Okay, so lesson part 2. We will look first at what we're going to do, how we'll run our program to begin with. Okay, before we did a rectangle draw, so this time we can, all right, we're already running, so we'll do that same rectangle that we did in the previous part of this lesson, part 1. No change there. Now, this time here we added a basic program. We'll give us some options. We'll do a 2 here. And just do some random lines all over. Okay, we'll get out of there and we'll do a 9 and we'll get out of here. Okay. Take a look at the code that we changed. This shouldn't take very long. And at the end of this here, I'll have a programming tip. Okay, so this is the same program we had. I think we had program 11 version D. We ended up, and I left off in this version E, but I left that off. This is the same, all the same include. That's all the same. And we'll get down here where we start. This all the same. And hopefully I did put all the changes. I put a note in down here in the code of version E. Okay, we added a 1 byte field in here called this path, because we're going to have multiple paths. Before we had the one path that did the rectangles. This here we're going to do the path 2 is going to do them lines. Okay, and in between here we got version E in between these two lines here. The basic program is going to scoot this back up at this path here, which is at E004. You can see over here. Okay, basic is going to poke in whatever option we're going to use, 1, 2, 3, or 4. And down here we're going to verify if that number is a good number, because we don't want to have number 9, because we don't have a 9. In fact, in this test case I got here, we only have 1 and 2. So it's standard code in here. Get this path. If it's equal to 0, use the default. If it's a minus number, use the default. Compare it to the maximum number we could have, which is 2. If it's higher than 2, use the default. Other than that, we'll just do some calculations and get done. Down here we're going to store the path address, the point path address, and we'll use that in the future. Okay, that was the changes for version E. Rest of this is all the same here. We didn't change anything in here. Nothing's changed. Okay. Get down here is 1 marked version E. In the previous version that you've had, version D, it loaded up, I think it was # path 1, because we only had 1 path. So now we've calculated that, beginning of this, we calculated the path pointer, we stored it, so we're going to use that as our, where we start, and our indicator is what we're going to do. All this is the same, nothing else changes, okay, until we get way, way down here. Here was our path 1 that we had before, all the spiral rectangles that was here. And now here's another version E notation. Here's our path 2. This is drawing them random lines that I put on the screen in the test at the beginning. So this goes, down right, down, up right, same as the other one did. Okay, then we added here a path table, and we put the address of each one of these paths. Okay, here's path 2, here's path 1. We're putting them to 2, and let's move over here and take a look at that. Okay, here's the address of path 1, here's the address of path 2, which you can see is 1070, so when it symbols, that's the address. How many paths do we have? We'll calculate that. We'll go from the path table to here, divided by 2, because it's 2 bytes entries. We end up calculating there's 2 counters, and then our path pointer. Okay, that's where we're storing we calculated at the top of this program, we're stored whatever address, one of these two addresses, and our default is path 1. At the beginning, remember, if we had a bad thing coming from BASIC, we'd use the default, which is 1. That's all the changes. That's it. Lock, stock, and barrel. Okay. Make them few changes to your program. You can do whatever you want. Now, I did not code in triangles and squares and stuff like that. That's for you to do. Okay. Now you see how to add a path. You can path, do whatever you want. I did make some notes down here at the end. Version E. Things you can do with this, you can add additional paths, one for the boxes and one for the triangles that I have in the BASIC program. You might want to add a color option or start address and stop address. Okay, here all we're doing is, our only options here was up, down, right, left, down, right, etc. That's our option, but you could change and put, let's say you wanted to add a color, the color option. Okay, you got to watch out in what you use here. Okay, here's what's all added that the program looks for. You might want to say, if it's a color change, you might want to use code CCCC. Okay, when you're going through your code, you see that all CCCC. You know that was a color change, and you can do something with that color. Same way with start address and stop address. Okay, you can put some other codes in there, like, I don't know, XX. You don't know, you can't use X. That's what, but you might want to E and FF. I don't know. Just you can figure it out on your own to add a start and a stop address. Okay, you may want to add some code because all of these use the same title message up here, rectangle spiral. Well, we know that we're doing lines. It's not what it is. You may want to add some code in here to, whenever you get a different path, you change the title on the screen. And one other thing to do, I could have done, but you can do it. Change the basic program to ensure option 8 runs first. Why do I say that? Because if you don't, the program's not loaded. It will definitely go haywire. Okay, I'm going to run this again. Okay, option 8 is load the program. That's the first thing you want to do, because like I said, if you don't, you branch out to start this program, it won't be in memory. So but you could change your, okay, I think I'm over here, okay. Like I said, if you don't change that option 8 to start with, you'll go to Never Never Land, okay. And that's what the program does, okay. You can add the code for 3. In fact, we've got the basic, I got the basic program, look at here. Basic program is really basic, okay. We got the POC address that was at 8 hex E04 is where we put the 1, 2, 3, or 4. And remember, we only got a 1 or 2, and it just ignores the 3 and the 4. The code is in here to poke at our POC address, either 1, 2, 3, or 4. That's it. You know, and this is all. You can streamline this or do something. That's pretty much what we're pretty much done here. Okay, so I'll put the code out there, and you can type it in yours. There's such few changes that won't make much difference one way or the other. Now, if I can get back to this, that's pretty much the end of part 2 of the line drawing. Okay, I've got a tip. Just have some on here. Okay, this is going to be a tip on helping you with your code. And what the use of a branch never is. The branch never, it says never branch, so why we do that, okay? And it's also for code modification. So this would be some normal program here if you have something, could be a game, or it could be anything, or where you got different levels or different routines to use. And here I just used level. You're doing level 1, 2, and 3. You could have 10 levels, you could have 20 levels, or whatever you're going to. And you can see there, you got to load up what the level is. You got to compare it to A, compare it to, you know, if it's equal, compare it to 2, to 3, to 4, to 5, you go on and on and on. Which, if you've got a game when you got 5 or 6 sprites going and other things changing on the screen, you're eating up a lot of cycles comparing to get down to levels 10 and 12. So you got a lot of cycles wasted doing compares. So let's change that main loop to look like this. It's branch never to level 1, branch never to level 2, and branch never to level 3. So, okay, well, as we would never branch. All right. So when you assemble this, a branch never gives you the operation code of 20 and a 2-byte address of how many bytes from here do I branch. Okay. You could use long branch never too. You just have to know that the opcode is different. Okay. So what does that mean? So there we go. And if you just, all you have to do is, oh, I'm sorry, this here says branch always. So when you come through it in the main loop, you always branch to level 1. When you're done with level 1, whatever you're doing, and it's successful, you want to go to level 2, all you have to do is modify this code here, this hex 20 to a hex 21, which is a branch never now. So it comes into the code. It will not branch because it's branch never. Now it's going to take 1 or 2 cycles, I believe it is, to look at that, but that's all. It's going to fall through and take this branch to level 2. Bang, you're at level 2. When you get to the end of level 2, you change this code here to a 21 and it will come in, branch never, go to level 3. So you can get through there without doing all these compare. If you only have 3 levels, you're not going to pick up that much, okay, but that's just one way of doing it. The other thing is you may have other subroutines within these levels that uses common code. For instance, putting a different heading on the screen. You could also modify that routine the same way. That way you wouldn't have to go into a routine that's going to say, what heading am I going to print on the screen? Am I going to do this level 1, level 2, level 3? You can do these branch nevers also. Okay, these has some pitfalls, and I'll share that with you in a second here. Another option is, here's our same main loop, and we're going to do a indirect jump to level address. Okay, well, how do we do that? Okay, so it starts out level address. Would have address of level 1 in there. So when you come into the main loop, it would jump to level 1. When you got done at level 1, you're promoting up to level 2. You load up the address of level 2, and you store that in level address. Okay, we've stored it, and the next time you come to main through, it says jump to an indirect jump to whatever's in there, and in there we'll have level 2. It will jump to level 2. When you get done with level 2, you change it to load X level 3, store that in there. Next time you come to main loop, it's going to do an indirect jump into level 3. Okay, so that's just another way to do it. And there's more ways to do it. That's just 2. And this is, believe it, this is good for COCO I, COCO II, COCO III, or any other programming language that you want to use. I mean, I used it back in the 70s and 80s when I was still a coder on IBM mainframes doing some offline programming. You could change it. We did this kind of stuff. Okay, some of the fallacies of doing that. Okay, if your program, you have an option in there that says exit, or you're done, and you're done with your game or whatever it might be you're writing. If you typed in execute again, guess what? Your program would be wherever you left it. If you happen to left it exit 3, that's where it would be. So your game would not start, your program would not start at level 1, it would start out at level 3 because that's where you left it. So that works also for the branch never option also. Or if you have another one, you get done the game and it has an option in your game says start over. Well, your code has been modified. In this scenario, you've modified the code. Here you've modified the code, and starting over, you have to have a provision for that. Or if you want to back up a level or whatever you're doing, is have a button that says back 1 level. You'd have to go back and undo all them fixes. And the other thing, if you have multiple users, okay, you really got to watch what you're doing because each one would be different. So you just can't change. One player might be on level 5 and one on level 7, and so this would be a nightmare of keeping track. You can, but you just have to make sure you got enough tables and pointers to handle that. So that's what the use of branch never and code modifying will get for you. Okay, and with that, we are kind of done here. Now, when I say done, let's talk what I mean by done, okay? I've put out 12 of these lessons and other things, and there doesn't seem to be a lot of interest. I've noticed that very few reads on any of these, and some of these, especially some of the longer ones I did, which takes time. I've been up to 8 hours putting one of these together. You know, it's an hour presentation, but the actual researching, the coding, the debugging, testing it on here, and testing on BCC, all the other pieces of making sure that the notes are correct and like that, and the actual recording it and editing the recordings and getting it online could take up to 8 hours for some of these. And I don't see a lot of interest. I've got a few thank yous and comments, but that's about it. So I don't see a lot of interest. So I do have a 12 in the works, which is one that hopefully everybody will like. But after that, unless for some reason, I may at time to time put other stuff out there, but 11 is it. And I got 12, and 12 is for probably a lot of people is going to use it more than anything else. If you have a basic program, but you want to use assembly language routines, a good, safe way to do that, and how to interact between both of the programs. So I'll work on 12. I don't know when I'll get it done, but unless I come up with a lot of comments or questions or something you'd like to see, we're kind of be done with this series. I mean, I'll probably come up with different things, not in the lesson series, but just how-tos and tips or stuff like that. Other than that, thanks for all the interest that there was out there. But as for now, we are done.